Hello, my name is Alex, and today I would like to solve an interesting GRE problem. What is the diameter of the largest sphere that you can fit inside of the right cylindrical cone of a base with the diameter 6 meters and a slant height of 12 meters? Whenever you have a geometry problem like this, the first thing you want to do is try to draw it. So I'm going to go ahead and draw a cylindrical cone, right cylindrical cone, and I'm going to try to draw a sphere inside of it. The problem calls for the largest sphere possible, and that would be a sphere that would touch each one of the sides, and that's what I try to represent here with this drawing. And then we can denote what we know from the problem is that the cone has the diameter 6 at the base and the slanted height of 12. So now let's read the problem again and see what the problem is asking for. It's actually asking for the diameter of the largest sphere. So we need to denote the radius of the circle, and then what the problem is actually asking for is 2 times this radius, and this would be your diameter. And also, whenever you're dealing with a geometry problem which is in 3D, what you want to do is try to bring it into 2 dimensions and use the principles that you learned on the 2D plane. Therefore, we're going to look at the cross section that is drawn to the right. Since it's a right cylindrical cone, we know that 2 sides of the triangle will be equal to 12, and the other one, which is the diameter, equals 6. So now the problem becomes, how do you find the radius of a circle that's inscribed in such a triangle? There is a formula that we could apply right away, but I believe it's really important that we understand where the formula comes from, because then you're more likely to think of it during the test. So now let's try to look how do you define the formula for the radius of the circle inscribed in the triangle. Let's take a triangle ABC and denote each of the sides as A, B, and C respectively. And now let's draw a circle inside of this triangle with the radius of R and a center D. If we go ahead and draw lines from the vertices of the triangle to the center of the circle, as a result we're going to end up with 3 triangles. We're going to end up with a triangle ABD, BCD, and CDA. And it's important to realize that those 3 triangles, when put together, they actually have the same area as the entire triangle ABC. So we can write it as a formula: area of the triangle ABC equals the area of ABD plus BDC plus CDA. And the good thing about those triangles is that their height is actually the radius of the circle, R. So we can denote the area of the triangle ABD as half times A times R. Similarly, BDC is going to be half times BR, and then CDA will be half times CR. When we plug it into the original equation, we get the area of the triangle ABC as half times AR plus half times BR plus half times CR, which we can also write as half times A plus B plus C times radius R. And when we solve this for R, we actually get the equation that we are looking for, which is the radius of the circle inscribed in a triangle equals to 2 times the area of the triangle divided by A plus B plus C, which is the perimeter. So now we can go back to the original problem and try to apply the formula we just found. Looking at the formula, we know what A, B, and C are. We know A equals to 6 and B and C both equal to 12. But what we're missing is the area of the triangle. In order to get the area of the triangle, we're going to need the height h. We're going to use the Pythagorean theorem. And we can clearly write that the height h equals square root of 12 squared, which is 12 squared minus 3 squared, which equals square root of 135, which is 3 square roots of 15. And now we can define the area of the triangle A as 1/2 times the base, which is 6, times the height, which is 3 square roots of 15, and we get 9 square roots of 15. And now we can go back to our original equation, r equals 2 times a divided by a plus b plus c, plug in all the numbers, and we get our answer, which is 3 over 5 times square root of 15. And let's remind ourselves what the problem was asking for. They were asking for the diameter, not the radius. So after multiplying the number by 2, we actually get 6 over 5 times square root of 15, which is our final answer. I really hope this was helpful, and if you have any other problems that you would like me to solve, feel free to send them to MathHelpGRE@gmail.com.